All right, guys. So let's start off with projectile question. Okay, we're going to start off with a super simple question. Question says that you kick a ball. Okay, we're going to just reword this question a bit. You kick the ball at a speed of 85 km per hour. Okay, so what I'm going to do is I'm going to draw my ground surface over here, and you kick a ball at an angle from a horizontal surface. Okay, so this is going to go like this. It's going to go up and it's going to fall down, and you kicked it at 85 km per hour. So you gave it an initial velocity at an angle of 85 km per hour. And this thing went flying 25 degrees above horizontal. When you kick the ball, it went flying 25 degrees above the horizontal. Now what's going to happen is, folks, they're going to ask you a bunch of questions. First question they're going to ask is, how far away is it going to land? Which is essentially distance of x. Now sometimes they might use the word range for it. So you should be aware of the word range. It's just distance of x. In other words, how far away will it land from the initial position? And that's just the horizontal position. Okay. Second thing they might ask you is, for how long was it in the air for? So they might ask you to find the total time. And then they might say, what's the maximum height that it's going to attain? Means what's the highest point it's going to reach above ground? Okay. Apart from that, another thing they can ask is, what's the velocity at impact? Means when it hits the ground, right here, when it hits the ground, what's the velocity going to be? Just another name for your VS. And finally, there's going to be a trick question, which is going to say, what's the velocity at the highest point, at the very top, at this point? That is your very top, highest point. So whenever you get these questions, folks, whenever you get these questions, the first thing that you need to do is you need to take this vector, which is 85 degrees, that's your initial velocity, and you need to break it up into its x and y components. So what we're going to do is we're going to take this vector and we're going to break it up into its x and y components. And the first thing, as you know, you should also be doing is to change this velocity from kilometer per hour to meters per second. Okay, so how do we change a velocity from kilometer per hour to meters per second? You just take this number and you divide it by 3.6. You know, if a velocity is ever given to you in kilometer per hour, divide that by 3.6, it'll change it to meters per second. So this will be 23.61 meters per second. Or you can just say 23.6. What this means is this hypotenuse is 23.6. This angle is 25. And now we're going to break this velocity, this initial velocity, into its x component and y component. So we're going to break it up into its x component and y component. Now how do we do that? Well, this is the angle that's given to you. So this must be my opposite. This must be my adjacent, and this is my hypotenuse. So guys, look at this. You have the hypotenuse, you have the angle, and let's say you're trying to find Vy first, which is the opposite. That means you want to use the ratio which uses ONH. Guys, if you remember your SOH, which ratio uses ONH? That's SOH. What that means is you're going to have to use sine theta. So you're going to say sine theta, when my theta is 25, is opposite, which is your Vy, over your hypotenuse, which is 23.6. So how do we find Vy? You're going to cross multiply this 23.6. So it'll be 23.6 times sine 25. That will give you your y component of initial velocity. Now, I had to show you these extra steps because it was your first time seeing this. Moving forward, what I want you to do is, you know, if you want to find velocity final, you would just say, this is O, this is H, we got to use sine, so it'll be 23.6 times sine 25. Moving forward, you should be just able to do that quickly. You don't need to do all these steps, okay? So make sure your calculator is in degree mode and type in 23.6 times sine 25. That should give you 9.97. Okay? Similarly, this velocity x component, this involves A and H, which is ta, which is cos. So this is going to be 23.6 times cos 25. So 23.6 times cos 25, let's punch it in. That gives me 21.4. Do you guys agree? So step number one in all of these projectile questions are to break it up, to break your initial velocity into its x component and its y component. Okay, that's the most important part. Once you've done that, folks, the rest is easy. What we're going to do is we're going to break this question up into its x component and its y component. We'll break it up into its x and y. Now you see, what's the velocity initial of x? Velocity initial of x is this 21.4 meters per second. Velocity initial for y, well, that's 9.97. Now we all know this is vertical initial velocity. Guys, whenever your object is free falling, going up or coming down, what's your acceleration all the time for vertical direction? Negative 9.8 meters per second squared. Remember that. This is not going to be given to you explicitly in the question. You're going to have to remember, whenever things are going up or falling down freely, acceleration will just be acceleration due to gravity, which is negative 9.8. Guys, and another thing, what I'm going to do is I'm actually going to split this question up into half. I'm going to say, you know what? I'm going to break it up and say this point is my final point. So let that point be the point of final velocity. Okay, so what that means is, now guys, tell me something. When you reach the highest point, an object, imagine an object going up. You know, as it's going up, it's losing speed, slowing down, slowing down. When it gets to the highest point, what's the velocity going to be? 0. At the highest point, the velocity final of y is going to be 0. Look, I have 3 pieces of information. That means I can solve now. I can find a missing piece. Well, we're going to find time. We're going to find time. And the equation we will use is, which does not involve d, which is Vf is equal to Vi plus At. Vf is equal to Vi plus At. That's the equation we're going to use. My Vf is 0, Vi is 9.97, A is negative 9.8, and T is what we're trying to find. Move this negative 9.8 to the other side. And then you'll just say time is going to be 9.97 divided by 9.8. Now that gives you how much? 9.97 divided by 9.8 gives you 1.017, so roughly 1.02. Now you have to keep this in mind. This is not your total time. This time that you found is not your total time, it's actually your half time. Let me explain it to you. Your object started here on the ground, and we're saying let this be the final position. Whatever time it takes this object to go from this point to the highest point, it's going to take the exact same time to go from the highest point to the lowest point, because they're at the same height, right? Same no displacement. So whatever time it takes to go up, it will take the exact same time to come down. Now, from that, what do you guys know? How can I find my total time? Can you guys tell me how can I?
Just multiply by 2.
Absolutely. And that will give me 2.04.
I also had a question. How would the final be 0? Won't the end point be 0?
Okay. Oftentimes people think that when it hits the ground, the velocity is 0. It's not 0. Imagine if you throw an object up, when it hits the ground, just before impact, it's got a velocity, bam. Yes, obviously, finally it comes to a stop, but that's like way after the impact. Right at the time of the impact, it hits the ground with a certain velocity. It's not 0.
Oh, so basically,
yeah, go ahead.
Yeah, so basically when an object is like almost about like it's going like at the moment of coming down, basically, when it's 0?
It's 0 right at the top. Let me explain you why. When you throw a thing up, imagine you're throwing an object, a ball, straight up. What's going to happen is when you threw it up, you probably threw it up at a really high velocity. As it's going up, let me explain it to you over here. This is the ground. You throw a ball up. Let's say you threw it up at 10 meters per second. Gravity is constantly pulling it down. Do you agree with me? Force gravity is constantly pulling it down. So what's happening to this object as it's going up? Its velocity is slowing down. At this point, maybe it's this. At this point, it's this. As it keeps going up, it's going to keep decreasing. Maybe this is 4. Now, what happens when it reaches the highest point? At that instant, when it reaches the highest point, it's got no velocity. It kind of pauses for a bit. So it halts for a bit, where it's at the highest point, its velocity is 0. Then when it starts falling down, now its velocity is going to start increasing again. So if it was 4, right at that point, it's going to be 4, but minus. Why minus? Because it's falling down. So anyway, if it's 6 at this point it'll be minus 6. So you see, it's speeding up now, right? When it's coming down, and you can always throw the ball up. You know, the best way to know if your ball has a velocity is just lie down on the ground and throw the ball straight up. When it hits you, it's going to hit you hard.
Got it.
Understood? So when it reaches the highest point, that's when the velocity is 0. Now keep that in mind. It's only the vertical component which is 0. That's part of this tricky question that we're going to do at the very end. This velocity, which is at the very top, you see, this is only the y component that I made 0. We'll talk about the x component in a bit. So let's come back to this time. When it goes from here to there, we found the time was 1.02. It's going to take the same time to fall down. So the total time is twice of the time that it takes to go up. 2 times 1.02 gives you 2.04. That's the total time. Once you find the total time, you say, you know what? Time of y is going to be time of x, because time does not have a direction. So whatever time you found for y, that's the exact same time you're going to have for x. So then we're going to go to x side, and we're going to say, you know what? The time for x is going to be 2.04. That is going to be the total time. Now, one thing you need to remember is this, folks. In your x direction, the acceleration is 0. You have no acceleration. Okay, why do you have an acceleration of negative 9.8 in y direction? Because of forced gravity.
Yeah.
Forced gravity is always pulling it down, and forced gravity gives you an acceleration due to gravity. That's what this is. But for x direction, there is no force being applied. No one's pushing this ball, or no one's pulling this ball horizontally. There is no force in the x direction. That's why the acceleration of x is 0. And whenever you have no acceleration, means it's moving at a constant velocity, then you can find the distance by using a simple formula, which is velocity times t, vt. Because there's no acceleration anymore. This is just going to be 21.4 times 2.04. Punch it in, folks. 21.4 times 2.04 is how much? Gives me 43.66. Do you guys agree?
Yeah.
Now that's how far it's going to land. That's this distance, the range. You can call it the range that it's going to cover. Okay, so what have we found so far? We found this guy. We found this. Now we want to find the maximum height. What's the maximum height? This guy right here is maximum height, which is essentially your displacement of y until that highest point. So now guys, what we're going to do here is we want to find the displacement. So on the y side, now we'll use the formula which allows me to find d. So I will say vf square is equal to vi square plus 280. Where vf at the very top for y is 0. Velocity initial of y is 9.97. Don't forget to square it. 2 times negative 9.8 is negative 19.6 times d. Let's move this term to the other side so it becomes positive. So you get 19.6 d is equal to 9.97 squared. 9.97 squared gives you 99.4. And now you just divide both sides by 19.6. Cancels, cancels. So what's your displacement? 99.4 divided by 19.6. That gives you 5.07. Now guys, that's your displacement of y. And that is your maximum height that this object is going to attain. So that is how you're going to get your maximum height. Are we good so far? Do we all understand this? Okay, now there's a bunch of other questions left. We solved this one. What's velocity at impact? Well, I'll tell you what, your job is made easier in this question. This object, it left at this position and it came back and it hit the ground at the same position. Can you guys tell me what's the displacement in y? Has it changed any distance in any position in y?
No.
If you leave the ground and you come back and hit the ground, in y direction, your displacement is nothing. You know, whenever you're at the same height, whatever velocity you left with, you're going to come back and hit at the same velocity. So you're going to say your velocity impact, which is your just Vf, is going to be exact same velocity, left at 23.61. So it'll come back and hit at 23.61 meters per second. Even the angle is going to be the same at 25 degrees. Now, the only thing is when it comes and hits the ground, it's going to hit at in this direction.
Won't
So
it
if
be
this
negative?
is your horizontal, you never put the negative on the angle. You never put the negative on the angle. What you can instead say is, you see this is your horizontal right here? You can say it's 25 degrees below horizontal. You can say it's 25 degrees below horizontal. You can put a negative. Some teachers might do that, but I like to say, I like to be more clear. 25 degrees below horizontal. That's your velocity at impact. Do you guys understand that? I'll tell you what.
So for
Yeah,
I have a question.
Go ahead.
For the next one.
Say that again.
It's for the next. It's for E.
Yeah, that's the tricky part that we're going to talk about now. Okay. Velocity at the top, at the highest point. That means I'm talking about this guy right here. What's the velocity at the highest point? Guys, I'll tell you what. Yes. How many of you guys think it's 0? Please say it.
Yeah, I think it's 0.
I do.
Agree? Does everyone agree?
Yeah. Congratulations.
You're among the 99% of the people who get this wrong. I'll tell you what, there's just a small trick. You know, the problem is, we say it all the time, velocity at the highest point is 0. Velocity at the highest point is 0. But usually we're always talking about the y component. Guys, for x component, the velocity is constant everywhere. Do you guys agree? What was the x component's initial velocity? 21.4. That means at all points, the x velocity stays 21.4. You can pick any point, the x velocity will always be 21.4. Same over here, x velocity will always be 21.4. Now tell me, at the highest point, you know, I'm talking about this point. Yes, I agree that my y component is 0. I agree that this component is 0, but your x component is going to be how much? 21.4. So you see, it's only your y component which is 0, not your x component. So when you want to answer this, you're going to say, because your y component is 0, the only component, the only velocity you have is your x velocity. So velocity at the top is 21.4 meters per second going to the right. That's the most common mistake. 99% of the people say 0 and they get this wrong. Guys, remember, at any point, if I'm asking you to give me the velocity at any point, I'm asking you for a combination of x and y. Not just x, not just y. A combination of x and y. These parabolas have a combination of x and y component for the velocity. Okay? So the y component was 0, but the x component stays the same everywhere, including at the very top. You know, it's always going to be moving in a horizontal direction. That's never going to stop. It's just the y component is 0 at the highest point. Do you guys understand that?
Yeah.
Okay, that's the tricky part in these questions, folks. Okay, once you understand that, the rest is simple. Okay, good, excellent. So that's how you're going to tackle all these questions. This is a simple version of your parabola question. Okay, this is a simple version of your parabola question. Let's look at more complicated ones. Okay, let's see if this one's complicated. Question says, a quarterback launches a ball to his wide receiver by throwing at 12 meters per second at 35 degrees above horizontal. This is exactly the same, guys. Just the numbers are different. You should be able to do this. Okay? So just make a note of this. Practice this question yourself. The concept is exactly the same. Okay, so now what we're going to do, guys, we're going to do some type 3 projectiles, which is a bit different, a bit more challenging. So let me give you a question here, folks. This time around, you're not throwing a ball from ground. You're standing on a building. You're standing on a building, and from the top, and let's say this building is 10 meters high. And from the top of the building, now you kick this ball. Now you kick this ball, which goes like this. And eventually it hits the ground. And you kick this ball at a horizontal, at an angle of, let's say, 30 degrees above horizontal. And with the initial velocity of 20 meters per second. With the initial velocity of 20 meters per second. Okay, so now they're going to ask you similar questions. First question, how far away is they going to land, which is displacement of x. Second question, what's the maximum height? Or the total time. Then the next question might be, okay, we got the total time, we got the maximum height. Then they might say, what's the velocity at impact? And what's the velocity at the top, at the highest point? Okay, guys, so this is not exactly the same as the previous question. Why? Because in the previous questions, you were throwing the ball, throwing the object from the ground. Now you're throwing it from a different altitude. But the first step is always the same. Whenever you have initial velocity going at an angle, we want to break it up. Okay, we want to break it up and we want to get that angle. We want to get the x and y components. So this is our velocity. We're going to break it up into x and y components. So let's say this is my x and this is my y. This is 20 meters per second. My angle is 30 degrees. We're going to find its y component. That is opposite. That's hypotenuse. So we want to use the ratio which has O and H, which is sine. So this is 20 times sine 30. Make sure it's in degree mode when you punch it in, folks. That's another mistake people make. That should give you 10. Then we're going to find velocity's x component, which is going to be 20 times. This is adjacent, so A and H, cos. 20 times cos 30. Can you guys punch it in? 20 times cos 30. It should be 17.32. Do you guys agree?
Yeah.
Now we're going to break it up into x and y component. First thing, what's my initial velocity of x? My initial velocity of x is 17.32. What's my initial velocity of y? That is going to be 10. What's my acceleration of y? Negative 9.8. Now here's a question for you guys. Now, can we just split this up into half and find this time and double it to get the total time? Can we do that anymore? We cannot do that, folks. We cannot do that. Why is that? Because now this object is going from this point to that point, which is a much shorter time than from this point to all the way to the bottom. So we cannot do that, but we can use one other concept. What's your displacement of y? Guys, do you know the explanation of displacement? Displacement is your final position. Okay, displacement is your final position minus your initial position. And we're talking just y. So this is, okay, how much further does it fall? This ball, when it goes from this point to this final point, how much has it fallen down? 10. That means displacement of y is negative 10. Do you guys understand that?
Yeah.
And now based on that, I can easily find my time. I can say d is equal to VIT plus half AT squared. Where my d displacement in y direction is negative 10, my velocity initial is 10, so it's 10t. And negative 9.8 divided by 2 is negative 4.9 t squared. I personally never like to see a negative in front of a t squared term. So I'll move both of these terms to the other side. I get positive 4.9 t squared minus 10t minus 10 is equal to 0. Now guys, you got a quadratic equation. It looks a bit nasty. So you can either use the quadratic formula Or most of you guys should have these advanced scientific calculators, which just allow you to punch these numbers in and they spit out the answer. Does anyone have any of those scientific calculators? Okay, guys, so when you punch it in, when you punch this equation in, which is 4.9 t squared minus 10t minus 10, you should get two answers for time. First is 2.76 seconds. And the second answer that you get is negative 0.74. Guys, can your time ever be a negative number?
No.
Nope, so you're going to ignore this. And you will say, this is my total time. This is mine. Let's call it total time. So now you know your total time that it spends in the air. You come to X and you say, you know what? My time for X will be the same. It will just be 2.76. So what's my displacement of X going to be? V times T. Simple formula because there is no acceleration. There is no acceleration happening in X. So it'll be 17.32 times 2.76. That gives you how much, folks? 17.32 times 2.76. It should be 47.8. Do you guys agree? Means that's how far it's going to land. Okay, so we found the time. We found the displacement of the X. Now we need to find the max height that reaches above ground. What we're going to do, guys, is we're going to first just find this displacement, which is displacement of Y. Okay, so for that, I will use a different formula in the Y side. It'll be VF squared is equal to VI squared plus 280. Where my VF at the highest point for Y is going to be 0. My velocity initial is 10 square. And 2 times negative 9.8 is negative 19.6 d. Move this term over here, you get 19.6 d is equal to 100. Divide both sides by 19.6. 100 divided by 19.6 gives you how much? It gives you 5.1. Now guys, is 5.1 my maximum height? Is this my maximum height? No, no. This is only this portion right here that you found. This is 5.1. But what's the height at that point? It's 10 plus 5.1. So keep that in mind. That's another common mistake. The maximum height is actually 5.1 plus 10, which is 15.1 meters.
And
are we good?
And then would you multiply by 2 or no?
No. Why would you multiply it by 2? Look, we're just finding the distance, not the time here.
Yeah, I got
this
it.
This distance right here is dy, and you add this further. Okay, that's the maximum height.
Yeah.
Okay, so we got the max height as well. We got the time. We got the displacement of X. Now the last thing I need to find is velocity at impact. Well, you see, when it hits the ground, it's going to come and hit the ground at this angle. So what does that mean? Well, what that means is that it will hit it at an angle. That means it will have a X component and a Y component. So we need to find VF, velocity final, for X. Well, as I told you, there is no acceleration happening in X, so that's going to stay the same, 17.32. Obviously, it's meters per second. That's velocity final X component. Now, how do I find velocity final of Y component? Simple. You just say it's going to be VI plus AT. Okay, what's my VI? 10. A is negative 9.8. And T, now I know my T is 2.76. So let's punch it in. 10 minus 9.8 times 2.76. How much is that, folks?
Negative 17.048.
Just 1 second. Negative 17.048. Excellent. So roughly we can say negative 17.05. Now that's velocity final's Y component. We got the velocity final X component and velocity final Y component. So we need to draw another triangle with those ratios. So we draw my X, which is positive. And then I'll have to draw my Y, which is negative. So x is positive, y is negative. How much is my x component? It's 17.32. How much is my y component? It's minus 17.05. We're going to find this hypotenuse, and we're going to find this angle right here. Okay, every single person, how do we get the hypotenuse? A squared plus b squared equals c squared. Can you punch it in and give me the hypotenuse? So it's 17.34 square plus 17.05 square, and then you take the square root of that. 24.3. Agreed? So now you're going to say when it comes and hits the ground, which is velocity at impact, is going to be at 23, velocity of impact is 24.3 meters per second at, okay, we need to find this theta as well. How do we find theta? Well, you know this is opposite, and this is adjacent, so I will use ONA, which is tan. So your theta is just going to be inverse tan of opposite. Opposite is minus 7, ignore this negative actually, 17.05 over adjacent, which is 17.35. Okay, everyone punch it in. Inverse tan.
44.5.
Let's have a look. 44.5. Did everyone get that?
Yeah.
Excellent. So now you're going to say your velocity at impact when it hits the ground would be 24.3 meters per second at 44.5 degree above horizontal. Does that make sense? Above horizontal. And can someone tell me what's the velocity at the top going to be? This is like anticlimax. Once you've done one question, then you know it for all. What's the velocity at the highest point? Means what's the velocity at this point right here? At that point, the y component is 0. Yes, the y component is 0, but your x component stays the same everywhere. So x component 17.32 is going to stay true. Do we understand that? So what are we going to say for velocity at the top? Well, you're going to say the y component is 0, but the x velocity is going to stay the same. So it will just be 17.32 meters per second towards right. And there you go, there you go, guys. This is how you're going to tackle your type 3 projectile questions. Okay? It's not so straightforward, but what was the key? Key was to realize that from this point to that point, the displacement in y was negative 10. Any questions, folks? Are we good? Okay. If at any point you have a question, just let me know. All right. So let's have a look at question number 11. Question number 11 says a pebble is fired from a slingshot with a velocity of 30 meters per second. It is fired at an angle of 30 degrees to the horizontal. If its flight is interrupted by a vertical wall 12 meters away, at what height does it hit the wall? So let's draw it out. So a pebble is fired from a slingshot with the horizontal velocity. Okay. Actually, it was just fired on the ground. So this will look something like that. So what's happening in this question is you fired it at an angle like that. And this is your building right here. This is your building, which is going to interrupt this flight. This pebble was fired at a velocity of 30 meters per second at 30 degrees. So this was flown at 30 meters per second at 30 degrees. Okay, so guys, this building right here, they're saying that this building is 12 meters away. This is 12 meters away. And the question says, at what height does it hit the wall? So they want you to find this height. At what height does it hit the building or the wall? Let's go, everyone. I want to see if any of you guys can figure this out. Everybody, let's go. All right, guys. So let's have a look at this question. What happened was you kicked this ball with the initial velocity of 30 meters per second. So you gave it an initial velocity of 30 meters per second, and you kicked it at 30 degrees above horizontal. So first thing that we're going to do, guys, is we're going to draw this out. We're going to break this up into its x and y components, the initial velocity. Okay. All right, guys. So let's have a look at this question again. So we take our initial velocity of 30 meters per second. Angle is 30 degrees from the horizontal. We break it up into its x and y component. We're going to first find its y component. This involves O in it, so it will be sine 30 times sine 30. If you punch it in, it will give you 15. What about my x component? Well, that'll involve cos, so it'll be 30 times cos 30. Punch it in, folks. What's 30 times cos 30? 30 times cos 30 gives you 26, roughly. So step number one, we broke the initial velocity into x and y, and now we'll make our x and y table. And we'll write down what's given to us. Well, I know my initial velocity for x is given to me. That's 26 meters per second. My initial velocity for y is 15. And I know my acceleration for y is always negative 9.8. I know one other thing, guys. When it hits this building right here, how much has it traveled in x direction? It has traveled 12 meters. So I know my distance of x is 12. So this time around, they've just given me a different value than the norm. Look, you know your acceleration of x is 0. So what's your formula for distance? It's vt. You know your distance is 12. You know your velocity is 26. And now we can find time. Divide both sides by 26. What's 12 divided by 26? 12 divided by 26 gives you 0.46. So time is 0.46 seconds. And that's the total time. So now you know your time. You go back to y and you say, now I know my time. It's 0.46 seconds. Look, I have 3 pieces of information. Means that now I can find anything. This h is pretty much displacement in y. So I need to use the formula for d, which is d is equal to vit plus half at squared. Okay, so let's punch in the values. Vi is 15, time is now, you know, is 0.46. A is negative 9.8 divided by 2 will give you negative 4.9, and t is 0.46, and we're going to square that. As long as you put brackets properly, you should get the right answer. So 15 times 0.46 minus 4.9 times 0.46 squared. That gives me 5.86 roughly. That's your height. That's the height at which it hits the building. Do you guys all understand this? You see how simple this question was actually? All you had to do was you use this formula. From there you get your time, put the time back into y, find the missing variable. It was literally a 2-step question. 3 steps if you want to include this break up part. Okay, so these are your type 3, means your non-usual projectile questions that you're going to come across. Do we have any questions? Okay. Guys, I want you to make a note of question number 12 and 13. You're going to do it at your end. Okay. Just to help you guys, here's the answers are at the bottom. So make sure you guys practice these questions so that you get the same answers that are listed at the bottom. But I've taught you all the concepts that you need to know, so you should be able to do these questions. All right, good. So we're done with kinematics now.